Hey, what's up guys? Welcome to this newer lesson on building a game engine in C++. In this lesson, we're going to focus on adding our graphics pipeline. Namely, we are going to create our shaders and get a triangle displaying on the screen. Now, hopefully this is going to be much quicker than the last episode, which was 2.5 hours, but we'll jump into it and see where we get to. Now, once again, I am using vkguide.dev as a lot of the base for this lesson because we need to get this base stuff out of the way before we can abstract it out to game engine stuff. So again, go to vkguide.dev if you want to see where this is. So today we're going to go through number 2. So let's just jump into that today. So without further ado, let's just jump in. And again, if you appreciate the work that I'm putting into these to help you out, I try to explain this a little bit more thoroughly, hit like, subscribe, leave a comment, all that crap. Okay, so the first thing we're going to do is we're going to create a couple shaders. Now, with Vulkan, you have a couple of options when it comes to writing shaders. You can either write it in the high-level shading language that you would use for DirectX, which a lot of people seem to prefer. I don't know any shader languages as it is, except for a little bit of OpenGL. So we're going to do GLSL in our project, but it's going to be very similar to how you're going to do it with HLSL. You'll just have to change a couple commands probably. So the first thing we're going to do is we're going to first create our shader files, and we're going to compile them, and then we are going to load them into the engine. That's going to be the first kind of step we get into here. So we're going to create our shader files first. So in our engine, not in our actual application, but in our engine itself, these are going to be our, we'll call these our default shaders or default pipelines. And we'll get into all of that as we go along. So we're going to create a shader folder here, which is going to be called shaders. And within our shader folders, we're going to create 2 files. There's going to be a triangle.vert, and we'll add this. So we got a triangle.vert and we got a triangle.frag. Now we're going to call it this for now, but we're going to probably rename it or add new ones as we move along. But consider this our default shader. I should mention that if you're running CLine, you can get a plugin called GLSL something. Yeah, you can go to this website and get this plugin, the GLSL support for CLine. And what that'll do is it won't give you autocomplete, but it will give you syntax highlighting for a lot of your GLSL stuff. So you can at least kind of do it in a little bit more visual way. So for Vulkan, we're going to start off, we're going to be using version 450 of GLSL, which I believe is going to be the version we need. And we're going to call it main. Now, I'm not going to go into the details of how shading language works, at least not for now, because I'm not that great with them yet. But we'll get into it eventually. Probably when we try to do stuff like lighting and stuff like that, I'm gonna have to learn it. So I'll impart my knowledge onto you. So what we're going to do here is we're just going to hard code in a triangle. So our vertex shader is the first step of our graphics pipeline, which determines where all the individual vertexes of a object lie in the scene. Now we don't have a camera or anything right now, so we are literally just going to put a triangle in screen space or window space, if you want to think of it that way, that will just draw a triangle. So we're going to make a const array of positions for the triangle, and it's going to be const vec3 positions 3 equal vec3 vec3 1.f 1.f 0.f vec3 minus 1.f 1.f 0.0f, and finally vec3 0.f minus 1.f 0.f. Do I need? Oops, that's that's the issue I did there. Parentheses. So that's how you declare we're going to declare our array. We can line these up so we can look at them a little bit more clearly. So in screen space, when you're looking at the window, your 0, 0 is in the middle of your screen. -1 is the left, or 1 is the right, and -1 is the top, and 1 is the bottom. So if you look here, we've got 1, 1, which is the bottom right, -1, 1, which is the bottom left, and then 0, -1, which is the top in the middle. So that's a triangle of 3 points that make a triangle. And then we output the positions, their final positions, by doing equal vec4 positions GL vertex index 1.0f. And that will be our vertex shader. And all this does, it declares a vertex. And then we're going to just basically say draw 3 vertices, and that gets passed in as GL vertex index. And that will just say vertex 1, grab 1, vertex 2, grab 2, vertex 3, grab 3. And if you look here, we're doing it in clockwise order, I believe. So that's what that looks like. And the clockwise and counterclockwise order of drawing vertices is important, and we'll probably see that a little bit further down. So in our fragment shader, we're going to do something very similar, except we are just going to set our color as red. Not red. Let's deviate a little bit. We've got a nice teal black background. Let's see if we can figure out what orange is. So again, version 450. And we need to declare the out frag color. So in OpenGL, I believe you would just declare your out color directly. I don't remember exactly how. I have it somewhere else on my computer. But in Vulkan, what you need to do is do layout location equals 0. Oops, location equals 0. Out vec4, and we can call this whatever we want, but we'll call it out frag color. So again, we do a void main, and we just set our out frag color directly. Out frag color equal vec4, and we are going to say RGB, whatever. I don't care. Let's just do it red. We'll do it a slightly funky color. We'll do this, whatever color that is. All right. So our fragment color shader is literally just this. It's going to output a color, whatever color this turns out to be, to out frag color, which will be displayed on the fragments themselves. So now we get into the issue of compiling these shaders. So I personally don't like to have to do things manually every single time. So what I do in my project is I have it that whenever we build the project, we will compile these shaders ourselves, right? So to accomplish this, we're going to need to set some more environment variables, and I'll show you how to do that. So first, let's look at my environment variables. We should see it here. Yeah, it is in here. I just saw it somewhere. Here it is at the top. So you see here, I've added the Vulkan SDK bin folder to my environment variables, to my path. But in Windows, you would go to your path. You could either do it system-wide, which is what I did. I put it in as a system, or you could do it as a user in here. So you would just go inside here, you would click new, and then you would click browse. And you would, let's say, pick this one, and you put it inside. But I don't want it. So what that would do, it will give it, so let's see if we can show you what we're using in here. So if you're in your Vulkan SDK and you go into your bin folder, you'll see that there's a bunch of tools in here. The tool we're going to be using is this GLSL or I believe it's GLSL compiler. which has very similar syntax, from what I understand, to like your C++ compiler. We're going to use this to build it. I believe GLSL lang validator might be the alternative to compiling it, or one of these SpearV ones. But what we want to do is compile our GLSL into compiled, I believe, SpearV shader files. So we're going to do that inside our CMake lists here. Okay, so now that we have our shaders written, what we need to do now is compile them, like I mentioned before. So what we're going to do in the CMake list file is we're going to add a couple of commands that are going to, before building the project, build our shaders, compile our shaders, and put them inside the binary directory so that they're accessible from the application. Make sense? So what we're going to do is, first we're going to create a comment, shader compilation. Then we are going to get all of our shader files by globbing them together, which is usually not recommended, but I don't have a problem doing it. So we'll do glob shaders, shaders / star.frag, and shaders / star.vert. And that will grab all of our Vertex and Fragment shaders. We're going to need a place to put them. So what we're going to do is we're going to say add custom command, and this is going to create a custom command within CMake, which is going to be it's going to be a target command for our project name target. So you look here, our target name has always been project name. So we're going to use that, and it's going to be a pre-build command. And what this pre-build command is going to do, it's actually just going to make directory. It's going to make this in CMake binary directory. So wherever your current build is outputting the binary, it's going to create a directory called shaders inside that folder. Make sense? Now with that folder created, we're going to create a for each loop. It's going to be for each shader in shaders. And we are going to end the for each here. And in here, what we're going to do is we're going to grab the file name component of the shader itself. So you'll see here, it's going to be get file name component. It's going to be the variable it's going to put out to is going to be shader name. It's going to get the shader as input, and what we want is the name of the file. So there's actually a new function for doing this in CMake called CMake path. I believe it's like this, CMake path, but that's only in CMake 20 and above, and for some reason my Visual Studio compiler refuses to use CMake 20, even though I have it installed and I pointed it to it. So we're just going to stick with the old way. So after we get the file name component out of there, what we're going to do, we're going to add one more custom command, which again is going to be the same target, project name. It's also going to be a pre-build command. And what this command is going to do is it's actually going to compile our shaders. It's going to be glslc-c, and then we pass it in the shader path itself, the path to our actual GLSL code, which is the -c, and then we give it an output to our binary folder here. So we'll do here CMake binary dir again /shaders, the directory we just created, and then we can take the shader name that we just had, shader name .spv, and that should work. So if we build this debug folder now, it's going to build, and you'll see here that inside our binary directory where our exe goes, we have a new shaders folder that has our triangle frag SPV and our triangle vert SPV, and that's what we were looking to accomplish. Okay, so that's everything we need to do. Now every time we build our project, and whenever there's a change to the project, it's going to rebuild our shaders, which is very useful. It means that we don't need to go in and manually compile stuff. So now what we want to do is we actually want to load these shaders in code. So I mentioned before that we have a Vulkan utilities here. And this is where we're going to start putting in some of our utilities. Namely, right now we're going to put our load shader module utility inside here. So the first thing we're going to do is we're going to namespace this. Namespace, what do we call this? Our namespaces are in Oz. So we'll namespace this into Oz, which we seem to have forgotten to do. And we will create stuff in here. So we'll also put the namespace Oz here so that anything generated will go in the right spot. Okay, so in our Vulkan utilities, we're going to create a new function. It's going to be called, it's going to be a static function that returns a Boolean called load shader module. We are going to take a const character array. Actually, let's make it an std string, which is going to be a const std string reference and file path. So we're going to take the device that we're going to be loading the shader into, and we are going to say vk shader module out shader module. So we need to import this stuff here. So here we're going to include vulkan/vulkan.h, and that will get everything we need inside. And let's define this function here. So this function itself is not going to be too difficult. It's standard input-output type stuff. So I think we also need to include fstream inside here. And possibly another thing, but we'll keep this. Yeah, and we'll also need vector. And I'll show you why in a minute. All right. So with those out of the way, let's do what we need to do. So first thing is we're going to create a input file stream that's going to be opened at the end of the file, and it's going to be opened in binary mode. So ifstream file path dot cstring ios at the end and ios binary. So what this does is it's going to open the file at file path. It's going to open it. It's going to position the cursor at the end of the file, and it's going to open it in binary mode. So read it as binary ones and zeros. Then it's going to fail. If it fails to open, it's just going to return false. And you could possibly put some error logging here, possibly, but we don't need it. We know if it doesn't open, then probably just didn't exist. Okay, so now what we're going to do is we're going to need the file size, so we can store it in a size t file size. And what this is going to be is, since we position the cursor at the end of the file, we can then just take the position of the cursor as the number of bytes in the file, which basically just tells us how big it is. So we're going to do a static cast size t file.tellg. So now we're going to create a buffer to hold the entire file. So we're going to create a vector uint 32t's called buffer, and the total count of this is going to be file size divided by size of uint 32t. So SpearV expects the buffer to be in uint 32t's, so that's why we store it in that format. So with that out of the way, we actually read the file. So we set the cursor back to the beginning of the file, and we read the file, read all the characters of the file into buffer.data and file size. And then we close the file. And with that, we have the entire file within our buffer here. The next step is going to be needing to create the actual shader module itself. So the shader module itself is going to be stored in a VK shader module, but we need to create it. So we go VK shader module create info, and again we will shader module create info, and as always we have the structure type shader module create info. So this one only takes a couple of parameters. So we take shader module create info, we take code size, which is going to be the size of the vector, so buffer.size times the size of the data format, which is going to be size of uint32t, which is what Vulkan expects. And finally we create info, shader module create info, and pcode, and we pass in the actual code buffer, which is buffer.data. And then finally, at the end of it all, we create the shader itself. So we do a VK shader module, then we do if VK create shader module device, and create info, shader module create info. We give it a null pointer as an allocator, and we give it our shader module. And if that is not equal to VK success, then we return false. And again, we might want to log a problem here. And otherwise, we set our out shader module, the value of our out shader module, to shader module, and we will return true. Now, I don't like using this pointer syntax, so I believe we can probably take this as a reference and probably just do this, right? And then in our Vulkan utilities, we'll also change this to a reference. Now, I believe that should work. If it doesn't work, we'll come back and fix it, but I think it'll be fine. All right, so with that out of the way, what we have left to do is we have to actually load these into memory. We'll do it hard-coded for now, but we're gonna, but again, we'll refactor everything later. So inside our Vulkan render, what we're going to do is void create render, create pipelines. And then we will create our pipelines. And here we're simply going to load all our modules, right? So first we're going to load our frag shader. So VK shader module triangle frag shader. And we do if not VK, no, Vulkan utilities. We didn't make that public, did we? So make sure we make this a public function. And then we can call load shader module. And here what we're going to do is we're going to call shaders triangle dot frag.spv. Then we are going to call with our device, which I believe we just called device. And our out shader module will just be our triangle frag shader. And if that's not true, we are going to say stdcap failed to load triangle shader module. I'll put a new line there. And then else, and we'll just copy this. And we'll just put successfully loaded triangle shader module. There we go. So that will load our triangle frag shader. Now let's do our vertex shader, which we'll just copy paste because it's the exact same code but with slight differences. So triangle vert shader, and that gets passed into here. This goes into here, and load triangle. Oops, forgot to put fragment shader. Fragment shader, vertex shader, and triangle vertex shader. Then in our init function at the top, we are going to call our create pipelines. So create pipelines. And let's build that. And when we run, we should see, ooh, file exists. Okay, so there's a bug in here. So what we can do ahead of time, we can do this, and what we're gonna actually just do is we're gonna call remove, and we are going to remove this shader if it exists. Okay, so let's try this again. Reload changes here. Let's build build this. Still says file exists. Oh, maybe if I add -p here. Okay, and I believe I might not even need this. Let's see. This should overwrite, right? Right. So one mistake I made when creating the CMake list is we want a -p here, which will just make it if it doesn't exist. But if it exists, it won't do anything. And let's run our project. And you'll see here, successfully loaded triangle fragment and successfully loaded triangle vertex shader. And this runs just as before. So we are officially loading our shaders, and now we can move on to the next step, which is going to be setting up our actual render pipeline. So what we're going to do is, again, the VK guide suggests you put it directly in your renderer or wherever you're doing it. I'm going to put it in its own C++ file here because it's more organized that way for me. So in here, what we're going to do is we're going to say, I believe we're going to call it pipeline builder. Yeah, we're going to call it Vulkan pipeline builder. There we go, and we're going to add that to the project. There we go, good to go. And what this is going to have, it's going to have a few things inside. It's going to hold every one of our various steps of our Vulkan pipeline in it. Yeah, just because we don't want to have to redo this all the time. So we're going to define a few things. We're going to, of course, need our vulkan.h. And we're going to need to include vector. And I think that's all we need for now. And inside our Vulkan pipeline builder, we will do vector, pipeline, shader, stage, create info, shader stages. And this is all going to be public as well, I should mention. And then this would be VK pipeline vertex input state create info vertex input info VK pipeline input assembly state create info input assembly, and then VK viewport. And VK rect2d, which is going to be our scissor. And then VK pipeline rasterization state create info rasterizer VK pipeline color blend attachment state blend attachment VK pipeline multi sample state create info multi sampling, and finally VK pipeline layout and finally a build pipeline function that takes a VK device and a VK render pass. All right, that was work. So again, we want to namespace all of this. And we will create this function, and oops, let's undo that namespace Oz in here, so that hopefully that will generate it in a better spot. Good. Okay. All right, so with that pipeline stuff scaffolded, we're going to go through and we're going to create all the initializers for a lot of this stuff, which we're going to put inside our VK initializers. So we're going to put this in here, and we're going to put render as initializers just to be clean. So the first one that we need is a static VK pipeline shader stage create info pipeline shader stage create info, but we will make that a capital letter. Do this, and our arguments will be VK shader stage flag bits stage. So VK shader module. So at this point, you could, I'm going to put leave timestamps as I always do. You could go through the chapter 2 pipeline walkthrough stage and implement all of these yourselves up into, most of these. Yeah, basically all the way up until we get to the pipeline layout, probably is where we're going to be done with our initializers. Yeah, this is pipeline builder, VKNet. So up at the color blend attached state. Yeah, so basically you could go through and do all these initializers yourself. I'm going to leave a timestamp to finishing the pipeline builder, specifically so that if you don't want to watch me type all this out, you don't have to, but I'm going to try to explain anything that I know details on as we go through, because that's the added value that I'm trying to bring here. Yeah, and again, we will be doing some refactoring at some point, some abstracting of a lot of this stuff, and we're going to go in depth further along in the series. But for now, we're just following a lot of this stuff. So let's continue. We're going to create the shader stage. So again, we're going to need to, I don't like the way this breaks it up. And so we are going to do this, and we're going to call it shader stage create info. Give it our structure type, shader pipeline shader stage create info, and we'll just return this object here. All right, so what does this take? This one takes a stage, which tells it which stage it is. So like if you're setting up a fragment module or a vertex module, this is how it's going to be done. So we can do shader stage create info.stage, and we will just pass in the stage bit that we took as a parameter. We give it the shader module, which is the compiled module that we just built inside our utilities function, I believe is where we did it. So we do module, and we put a shader module here. Now in C++ 20, module becomes a keyword. And you might get IntelliSense error on this line here. You can just ignore it, but just so you know, that is a thing. And now in our shaders themselves, if you look inside here, we named our main functions main as that's basically convention. For old GLSL, when you're using OpenGL, it had to be called main, but in with our Vulkan shaders, they don't need, the function doesn't need to be called main. You can call it whatever you want, and you have to tell it what the function name is here. So save pname equal, and we just call it main. And the reason we call it main in both is just so that we can We can abstract this out if every one of your shaders had a different entry point name. You would have to probably pass it in as an argument here. All right, so that's initializer 1 complete. Vertex input state. So that's the next one. So this one here, static. VK pipeline. Vertex input state create info pipeline. Vertex input state create info. VK shader. All right. So this one takes no arguments, so that's good. We'll just generate this, and we will keep that. Pipeline vertex state create info VK pipeline vertex stage input state create info. And now in here we have all right, so here it gets a little bit more complicated. Right now we are creating no vertex bindings or attributes. So in OpenGL, this would have been your like VAO, vertex attribute object configuration or something like that. But here we don't have any vertex bindings or anything. No vertex bindings or attributes, and we'll see this stuff later. But pipeline vertex dot vertex binding description count equals 0. Pipeline vertex dot vertex attribute description count equals 0, and that's all we need for that one. The next initializer is for our input assembly. So if we want, this is where we're gonna say, like, if we want to do it as triangles or lines or all that kind of stuff, that's where we would do it here. So we do static VK pipeline input assembly stage create info pipeline input assembly state create info. Here we just take one argument, and it's called primitive topology. And we will generate that. Again, we can remove that. We'll remove all of it, and we will do pipeline. And again, VK structure type pipeline input assembly state create info, and then pipeline state create info topology equal topology. And this was not explained in the tutorial, but I don't remember exactly what this was for. It was something along the lines of if you wanted to. I'm not going to pretend to know what it is. I have what I think is a definition in my head, but I don't want to give you bad information. So for now, put it as false because we're not going to use it, at least not during the VK guide dev stuff. But as we move forward, we might revisit it. So let's put this back on one line, and that one there is done. All right, we're moving along here. So the next step is the rasterization step. So this is where we set line width, and if we're doing wireframe versus filling in our geometry and all of that stuff, that's in the rasterization step. So this create info is specifically to set all that stuff up. So pipeline rasterization state creation pipeline in rasterization state create info, and in here we are going to take a VK polygon mode, and that's going to be the only parameter we take for that one. We'll generate that one here. Again, we'll do our style cleanups for what I prefer. You can do whatever you want. All right, so we need to create this pipeline structure type pipeline rasterization state create info. All right, so this one takes a few more arguments. So the first one is depth clamp enable, which we are going to set to VK false, which I believe it clamps all of our depth values that we pass into the rasterization state between like 1 and -1 or something like that. But well, we can revisit that another time at some point. So the next one is pipeline rasterization, and then rasterization discard enable. Again, it's going to be VK false. So this is useful, from what I understand, for if you're doing compute shaders and you're not actually going to be drawing anything in this pipeline. What this does is it just basically discards everything, makes it so that it will never render. If you put this to VK true, it's going to render nothing. All right, finally we have the polygon mode, which is basically what I said before. It's where you're going to get stuff like wireframe or filling or stuff like that. So pipeline rasterization state create info, line width. So this is self-explanatory. If you were in wireframe mode, how wide are your lines? Then we have cull mode, which we're going to put no culling. So if so here you'll see here there's cull mode back, cull mode front and back, cull mode front. So basically it's going to not render one side of the face. If you put it on back, it won't render the back face. If you put it on front, it won't render the front. Front and back is going to be both. And none is it renders everything. So we're just going to render everything in this case. And this is where you can see here, I mentioned earlier that our triangle that we were drawing was being drawn in a clockwise fashion. So if you remember, if we go back to our triangle triangle vert, it goes bottom right, bottom left, and then top middle right, and that's in a clockwise fashion. So this is where we tell it, okay, we want to make our front faces, the ones facing us, the ones that are going to be drawn usually if we have cull face back on, we're going to make that clockwise, and you can put it counterclockwise as well. Now the depth bias stuff is I'm not entirely sure what it does. We're going to set it to false, as you'll see, but I believe it's basically so it skews your results in a different towards a different depth bias. So if you want everything to appear a little bit closer than they are technically defined in memory on this particular pipeline, you can set a depth bias. That's my understanding of it. Again, I love corrections, so correct me if I'm wrong. Depth bias enable equal VK false, and pipeline dot depth bias constant factor equals 0.f. Pipeline rasterization depth bias clamp equal 0.f, and pipeline dot depth bias slope factor equals 0.f, and then finally we'll return the pipeline there. All right, so that one's done. Multi-sampling state. So we are not going to be using multi-sampling in this, at least beginning parts. We might implement multi-sampling later, which is actually probably something I'm going to be interested in. But for now, we're going to create a multi-sample state create info function, multi-sample state create info. And for this, it's not going to take any arguments. So in here, again, we're going to clean this up. And we're going to do, oops, we don't want the whole thing. We want just this, and pipeline, and VK structure type multi-sample. There we go. All right, so this one here, what does it take? It will take a, first we're going to tell it whether or not we're going to enable multi-sample shading. So pipeline dot multi sample shading enable equal VK false. And you'll notice that most of this stuff is just going to be disabling stuff or no multi-sampling. So again here, and then we will do rasterization samples, and this is going to be VK sample count 1 bit, meaning no multi-sampling. And everything else we're just going to be setting a bunch of default values to. So min sample, we're going to put minimum 1 sample, and then we're going to put sample mask. It's just we're not going to be not going to have a mask. Then we are going to alpha to coverage. I don't even know what that does, but we're setting it to false. And this one here, we're going to do alpha to 1. And again, we set it to false. I don't know what it does. Again, a lot of this stuff would be where you return to once you want to implement different features into your application. So when we want to do multi-sampling, there's a very high probability that we're going to be visiting this area right here. Okay, the next one that we're going to do, and this actually looks like it's the final one, is we're going to create a static VK pipeline color blend attachment state. Color blend attachment state. And again, this one takes no arguments as well. Generate that, delete that, copy this, add it in, create a variable, VK structure type, pipeline, color, blend, attachment, blend state, create info. No, that's actually not what we want. We're not this is not a create info struct, so we don't need that. I got ahead of myself. So here we will do our pipeline color blend attachment, and we are going to say a color or write mask. So what we're going to do here is we are going to write all the R, G, B, and A components, and we're going to disable blending. So blending, I believe, is where you're going to see a lot of stuff like transparency be implemented. So if you have like a multiply or just a window, stuff like that, that's what you would do it in your blend, your blend attachments. But we don't have that, or we're not going to do that for now, and we are definitely going to visit that at some point because it's something that's been on my to-do list to take a look at as well. So color R, G, B, and VK color A bit, and then we will disable blend, and then we'll return our pipeline color blend attachment state. All right, so that is that's all of our initializers. I know that was a lot, but it's going to save us time later not having to do this over and over again. So we're going to go and finish off and work on our pipeline builder now. We're going to actually implement this build pipeline. So what we're going to do here is first we are going to make our viewport from our stored viewport and scissors. So what we're going to do, VK pipeline viewport state create info, and viewport state, and as always we put our structure type, viewport state create info. Put our structure type whenever we're doing a create info struct. So our viewport state is going to have a viewport count, which is going to be 1, and it will have p viewports, which is going to be our end viewport. It's also going to have a scissor, which is going to be basically the same thing, scissor count equal 1, viewport state dot p scissors equal end scissor. And now we're going to set up some dummy information for color blending. We're setting it all to no blend, but we do have to write the color, so that's what we're doing here. Pipeline color blend state create info, again color blend state create info, VK structure type pipeline color blend state create info. This one here is going to have a color blend state logic op enable equal VK false dot logic op, VK logic op copy, which means we're just going to copy everything. We're going to have one color blend. We're going to have one color attachment. And we are going to attach our attachment. So end color blend attachment. There we go. All right, so now we're going to build the actual pipeline itself now. So now VK graphics pipeline create info, pipeline info, and VK structure type pipeline type graphics pipeline create info. All right, so our pipeline stage count is going to be equal to our shader stages dot size, and our pipeline p stages is going to be equal to a shader stages dot data. So this is just passing in all of our shader stages, right? And this is a pipeline shader stage create info struct, right? Now our input state, and we're just going to basically connect everything that all of the stuff that we have there. So p vertex input state equal vertex input info pipeline. Oops, we want this to be a reference. P input assembly equal end input dot p viewport state equal end viewport state. Oops, don't need the underscore. Pipeline dot p rasterization state equal end rasterizer. Pipeline creation info dot p multisample equal end multisampling. Pipeline create info dot p color blend state equal end color blending. What? Oh, this is again color blend. That's the one we just created. And pipeline info dot layout equal pipeline layout. Pipeline create info dot render pass equal pass. Pipeline create info dot subpass equals 0, which means no subpasses. And pipeline create info dot base pipeline handle equal VK null handle. So let's go over this fairly quickly. So a lot of this is self-explanatory. We connect all the stuff we passed in. We tell it which render pass that this pipeline is for, and we tell it that it is not building a graphics pipeline based on another pipeline. So you can do kind of like graphics pipeline inheritance. That's what this is for. I don't know how it works, but that's what this is for. You would give it a pipeline to like existing, like you could do existing pipeline here, existing pipeline handle, and then it would inherit a lot of the stuff. All right, so now we create our actual pipeline, new pipeline, and again, if VK create graphics pipelines. So you can create multiple pipelines at a time, but we're only going to do one at a time here. So the first thing we pass in is our device, which we passed in, which is not underscore, it's just device. The next one is going to be whether or not we have a pipeline cache. I don't know how that works, but it's a cache of pipelines, I imagine. We're going to create one pipeline, and we are going to pass in the pipeline info. We are going to not have a custom allocator, and we are going to put this into new pipeline. And if all of that is not equal to VK success, then we are going to return a null handle, and we're going to print out an error count. Failed to create pipeline. Return VK null handle. And we imported IO stream now. There we go. and then else, otherwise, we're going to return new pipeline. All right, so now that we've got our pipeline creation stuff being done, what we need is we also need a pipeline layout. So the pipeline layout is actually a full object, so you need to create it separately from the pipeline itself. Yeah, so the pipeline layout is used to describe the inputs that a certain pipeline will accept to be bound to the various stages of the pipeline. Let's go ahead and start building on that. So we're going to do one more thing in this initializer function, and this is going to be our create our pipeline layout create info. We're going to create it empty for now because we are not we don't need to bind any data to it. We'll see that in future lessons. So static vk pipeline layout create info pipeline layout create info. And right now this takes no parameters, and again we'll just do our little cleanup here. Pipeline create info vk structure type pipeline. Do we need this? Yeah, structure type pipeline layout structure type. What? Oh, I misspelled it. That's why. Pipeline layout create info. All right. So this one, we're going to have all the empty defaults. So I don't think we even need to fill any of this out right now, but we will, just so we can come back to it later. So pipeline flags equals 0. We're not going to put any flags. Pipeline dot set layout count equals 0. Pipeline layout dot pset layouts equal null pointer. Pipeline layouts push constant range equals 0. And info.p push constant ranges equal null pointer. Now, don't fret too much that you might not know what all of this means. Here, the set layouts are going to hold descriptor set layouts, which are going to describe the information that you're going to be passing into the shaders. And the push constants are small amounts of information that you're able to push into your shaders without having to declare a buffer and stuff. So we'll see these things as we move forward, but for now, just know that that's roughly what they do. Okay, so finally, with all of that, we can start doing some stuff. So now we are going to go into our Vulkan renderer, and we're going to start creating some stuff. So we got render passes here, synchronization objects. Where do we want to put our pipelines? We'll put our pipelines near the bottom. Our pipeline stuff near the bottom for now. Pipelines. Okay, so our pipelines, we're going to put vk pipeline layout triangle pipeline. Oops, triangle pipeline layout. And then inside of our create pipelines function, after all of this, we are going to create our pipeline. So we're going to do vk pipeline. We could do that, or we could just do this, because pipeline layout info equal vk Vulkan Initializers and pipeline layout create info. And then we are going to vk check that and vk create pipeline layout device. Create info is going to be our pipeline create layout info, right? It's going to be a null allocator, and it's going to be end pipeline layout. VK pipeline layout. Oh, of course. There we go. So I just used auto there to make it so I don't need to type out the name again. All right, so now with that created, we can create the triangle pipeline. So again, we are going to go back into our renderer.h in where our pipelines are, and we are going to say VK pipeline triangle pipeline. There we go. And this is where we have a big chunk of code here. So here, this is going to go away eventually. So temporary pipeline building. And this will actually end up very likely, I believe that this all ends up in a shader class of some kind. So I'll show you what that looks like. Yeah, so here, you'll see here I have a shader class, Vulkan shader, and there's a build pipeline function. And we call it from our constructor here of our shader. So we load it and then we build our pipeline. And that's basically what we're doing here, but we're doing it inline instead of as a separate object. All right, so with that done, Vulkan pipeline builder, pipeline builder. Now that's not going to be here. We're going to need to import that. So let's do that. Oops. Yeah, there we go. It's there. There. So I've imported it. I used a shortcut, but make sure you can go to top, include Vulkan pipeline builder there. And then let's start building our stuff. So pipeline builder, pipeline builder dot shader stages dot pushback. And here we are going to push back a Vulkan Initializers pipeline shader stage create info, and this is going to be our vertex shader. And we are going to say triangle vert shader, right? And we can delete that and make that like that. And we're going to do the same thing, but with our fragment shader. So we're going to push our fragment shader back. VK shader stage fragment bit and triangle go frag shader. There we go. So that will load our shaders that we defined and load it up here. The next step will be to basically just put in all those structs that we need. So pipeline builder dot vertex input info equal VK Vulkan initializer vertex input state create info. There we go. So we'll comment this. So here, this one, the vertex input state create info is we tell it how it reads the vertices from the vertex buffers. So vertex input. Well, you go to vkguide.dev. There's comments in the code that explain all this. I'll do it verbally, and you can just try to remember. As mentioned before, the assembly is how we tell it to whether or not to do triangle lists or strips or individual points or lines or stuff like that. So we tell it what kind of primitives to use to draw the different vertices. So Vulkan initializers, pipeline, input assembly stage create info, VK, primitive, topology, and you see there's a bunch of different ones here. What we're going to do is we're going to do topology triangle list. So we want to build the viewport, and right now our viewport is going to be the entire window, right? So build the viewport. And again, this viewport is actually going to change eventually when we go into VR as well. So it's a good thing to know about how this works a little bit. So pipeline builder dot viewport.x. We're going to do this because we're in C++20.x equal 0.f dot y equals 0.f. I like it the way it looks like this better than doing it in two lines. This is 4 lines instead of 2 lines, but I think it's it's easier to add more and add less, add more in the future. All right, so and actually I can show you that now. So here dot width equal static cast float window extent dot width, and copy that, and we'll make this height. Now this might not be in order, but I think CLion would warn me if CLion will warn me if I put it in the wrong order, so that's fine. And then min depth static cast float. No, not static. 0.f and dot max depth equal 1.f. There we go. So we've defined our viewport as having a width and height and a min and max depth. So 0 depth is going to be the front, and 1 depth is going to be as far in as you can go. All right, we will do the scissor now. Pipeline builder dot scissor equal dot offset equal x equals 0 dot, actually here you need to, sometimes you need to make a judgment call of when it's actually worth using new stuff versus using old stuff. Here we're only doing a couple of things, so we will do window extend like that, and that looks better than trying to break it up even further. What else? We have the rasterizer. We're going to need to do the rasterizer. So the rasterizer tells it how to draw how to fill the different triangles, right? So rasterizer equal Vulkan Initializers dot pipeline rasterization stage create info VK polygon mode. See here, yeah, polygon mode fill, polygon mode line, which is like wireframe. We're going to just use polygon mode fill. Pipeline builder dot multi-sampling. We have no multi-sampling, so we're just going to use the default multi-sample. And CLion is great at guessing which one I want. Pipeline color blend attachment equal Vulkan Initializers dot, look, attachment state. Look at that. It already knows which one I want. And then finally we give it the triangle, we give it the pipeline layout. There we go. And then finally at the end, what we're going to do is we are going to actually build our pipeline. So triangle pipeline equal pipeline builder dot build pipeline device, and it's going to be render pass, right? Yeah. There we go. So we've built our pipeline. So we've created our pipeline to actually render the triangle. So now we can actually do it. So if we go back to our render frame, in between here, you notice here I put the draw calls comments. So what we want to do is we want to bind a pipeline, vk command bind pipeline. We give it the command buffer. vk, we tell what pipeline, command pipeline bind point graphics. Bind it to our graphics pipeline, and we're binding our triangle pipeline, right? And then we draw, command draw. And if you look here, it takes command, it takes a vertex count, which is 3, 0 instances, first vertex, 1 instance, first vertex is 0, and first instance is 0. There we go. Now, if all is red, we should have a funky colored triangle. If it doesn't, then we can learn how to debug together. And look at that, we've got our funky colored triangle. So you'll notice when we delete everything, when we close everything, when we close the project, we're getting some errors here. Now we should make sure that to destroy everything. So we're not destroying the shader module. So we can do that at the end. So after we've created our pipeline, we can actually destroy our actual shader modules here. So we can actually go here and VK destroy shader module device, and shader module is going to be triangle frag shader null pointer. VK destroy shader module device triangle vert shader null pointer. So that should clear a couple of errors. So let's see where we're at once we do that. So again, it's still showing. You see I've destroyed it in the function in the create init, but it still has it because it was created in the pipeline. Close that. And now we've still got a couple. We've got pipeline layout and the pipeline itself, which makes sense. So now in here, we do it in reverse order, create pipelines with last. So we will do it here. VK destroy pipeline device triangle pipeline null pointer. I believe that's how that one goes. VK destroy pipeline layout device triangle pipeline layout null pointer. Now I just noticed that I misspelled triangle pipeline here, so I'm just gonna fix that quickly. There we go. And now we should have all of our validation errors fixed. Boom, there we go. Okay, so now that we've got our triangle drawing here, what we're going to do is we're going to set it up so that we can actually pass in different colors to the fragment shader from our vertex shader in order to make this a little bit neater or neato, as some people like to say. So what we're going to do is we're going to change our shaders just a little bit. So if we want to pass data between our shaders, let's open our shaders side by side here. These are our shaders right now. So if we want to pass our data from our vertex shader to our fragment shader, what we want to do is we want to declare an output variable here and then an input variable into our fragment shader. So I'm going to show something on the screen at some point, maybe right about now. You'll see that all the various stages of the graphics pipeline in here. And you'll see the vertex shader comes first and the fragment shader comes later. So that means we can pass stuff from our vertex shader to our fragment shader. What we want to do is we want to declare an output variable here. So we're going to do a layout location equals 0, output vector 3 out color, right? And then inside our fragment shader, we're going to declare an input variable here. And this is going to be a layout location equals 0 in vector 3 in color. Now the important part is that these locations match. These locations at the top. The names, as you can see, they don't match. I believe in OpenGL they match by name, but in here they match by location. The names don't matter. So we're going to set up a similar thing. We're going to set up a colors array inside here. We're going to call this colors, and we're going to change it a little bit so that we just have one corner that is red, one corner is green, and one corner is blue. So we can delete all the extra spaces here to have them line up. I like lining up my numbers when I do this. And the way we're going to do this is simply we're going to set our out color to be our colors GL vertex index. And that's as simple as it gets. So what this is going to do is just like the GL position here, where GL vertex is going to be 0, 1, and 2. This will pass out for each vertex 0, 1, and 2 of the various colors. So in theory, if I know this right, the bottom right should be red, the bottom left should be green, and the top should be blue. If that's how I read this. Now what we do inside our fragment shader is actually relatively simple. Is inside here, what we're going to do, we're going to say here, instead of vec4, we're going to say we're going to keep it vec4, yes. But instead of a hard-coded color here, we're going to say in color. And there we go. With that, we should be able to build. So we'll build this. And will that be what we need? No. So this is the issue that I want to make sure to point out. So you notice how here it's still running our old shaders. That's because we didn't, when we built our project with the build button here, you notice it basically goes straight to 100%. It's because there was no new code added to your project, right? So what you can easily do for that is just remove an empty line of code and save it, and then just build. And what that'll do is it'll force a rebuild. So now we're getting a error inside our shaders, which is good. That tells us that it's rebuilding the shaders. So what's our error? The first one is in our vertex. They're all in my vertex. Out color does not exist. Out color had a U on it. And colors had a U on it. And that's what happens when you are Canadian. There we go, we built it, and we didn't get errors that time, but you saw that it relinked everything, and that's the important thing you want to see. If you see it relink, it means that it processed the full build, and now we've got RGB, like we said. And as you notice, it interpolates between the colors here, and that's just some magic that that the Vertex shader will automatically do for you as you pass values out into the fragment shader. Now there are ways to pass in a value that will not interpolate, and we'll get to that as we reach uniforms and descriptor sets and all that. But for now, that's all we need. All right, so with that, we've come to the end of this lesson on Vulkan shaders and how to render our first triangle in Vulkan. Now I understand that it might not be as exciting as you want still, but next time we're actually going to go into building a basic input manager for our game engine so that we can toggle between two shaders. After that, we're going to go back into Vulkan and draw some meshes, and you'll see that as we move forward, things are going to get a lot quicker when it comes to Vulkan because we've done a lot of the scaffolding. So thanks for watching. Hopefully you enjoyed this. Hopefully it helped. And again, like, subscribe, all that nonsense. See you next time.